Hello and welcome to Science with Mrs. Blackburn. This is our second Laws of Motion video. I will have a third sometime soon. And today we're going to talk about the universal law of gravitation, and also I'm going to throw in a little bit about frictional forces into this video. So here's what we're going to get out of it. Our learning targets are to be able to explain the universal law of gravitation and to describe how frictional forces are going to work. So let's go ahead and start talking about gravity. Okay, so what is gravity? Well, it is a non-contact force. It is going to be an attractive force that exists between all objects that have mass. Okay, and again, non-contact means, if you watch the last video, you'll remember that it means that materials don't have to be touching each other with a non-contact force for that force to be applied. Okay, so there's something that we need to know about gravity. We have something called the universal law of gravitation. Anytime you see the word law in science, your ears need to perk up just a little bit, because that is something really important. Okay, and so who came up with this law? If we're talking about physics and you guess Isaac Newton, you are probably right. And actually, he is the one who came up with the universal law of gravitation. And you know how I feel about Isaac Newton. He was pretty awesome. So, what does this law say? Well, it says two main things. Number one, that things with mass have a gravitational pull. So anything that has mass in the whole wide world, or the universe even, are going to have a gravitational pull. This applies to things as big as planets or stars and as small as atoms or molecules. Everything that has mass has a gravitational pull. It also says that gravitational pull that we're talking about will depend on the mass of the objects and the distance between the objects. Okay, and actually there is a big equation that goes with this, and when you take high school physics you will actually be able to use this equation. We're not quite ready yet for that, but you just need to know basically what this law says. So things with mass have gravitational pull, and that the gravitational pull will depend on two things: the mass of the objects and the distance between the objects. So let's look at this little diagram together. So we got some marbles, and we're going to just kind of analyze what's going on with their gravitational pulls. Okay, so in the left diagram we say that the gravitational force of these objects will increase if the mass of at least one of the objects increases. So bigger objects have a larger gravitational pull. Okay, now the opposite thing happens as you increase distance. So if you increase the mass of an object, its gravitational pull increases, but if you increase the distance between two objects, the gravitational pull will decrease. So over here on the right hand side, we're going to see that the change in distance will decrease as objects move apart. So we've actually discussed this a little bit before in class. If you reach in your brain way back to the fall, when we talked about space science and we talked about the Earth, Moon, Sun system and even our solar system, and then we went out and talked about galaxies, and we knew that gravity determines a whole lot of what's going on in space. Okay, and one of the things that we talked about was that we have some ginormous stars and galaxies out there that are millions of times bigger than our sun, which is a star. Well, why, if mass determines a gravitational pull, why aren't some of those giant stars that are way far away pulling us toward them? Well, the reason why is because they are so far away. So mass and distance kind of have to play together to determine the strength of gravitational forces. So that's pretty cool. I love science, because when we talk about one branch of science, we always have to bring in others. So even though we're talking about physics, we have to talk about space a little bit too. So let's move right along. That was a non-contact force. So let's talk about a contact force. Let's talk about friction. So what is friction? Friction is going to be a force that resists the motion of two surfaces that are touching. Notice the word touching. So materials have to touch for the frictional force to be applied. Okay? So there are actually three types of friction that we're going to talk about today. The first type is going to be static, the second is sliding, the third is fluid, and we're going to go through each of these really quickly. This is actually pretty easy because you experience each of these on a daily basis. So let's talk about static friction first. So in each of these, I'm going to kind of take you through different scenarios so you can wrap your mind around what is going on with each of these different types of friction. So with static friction, let's say that you had to move a piece of furniture, let's say a couch, okay? And you go and you try to push it, and it's a really, really big, heavy couch, and no matter how hard you push, you're not able to move it, okay? So the word static actually means non-moving. If something is static, it is not moving. So with static friction, that is when a force is being applied to an object, but an equal force is being applied from that object back to where no movement is going to be able to happen. So like no matter how hard you push that couch, it's not going to move. So let's look at what this would look like with our little arrow diagrams. By the way, these are called free body diagrams when you draw these little arrows of different sizes and different directions to show what's going on with motion. So let's say that as you're pushing, the hardest you can push is 100 newtons, okay? Well, if the couch isn't moving and you're pushing at 100 newtons, how many newtons would the couch be pushing back at you? We don't really think about a couch pushing back, but if we push something, it's going to push back. We'll talk about that a little bit later too, by the way. So it's actually going to push back 100 newtons. So positive 100 newtons plus negative 100 newtons going the other way would be what? What would that be? It would be 0. No movement would be happening. That's why it's called static friction. So if we're pushing on the couch at 100 newtons to the right and the couch is pushing back at us at 100 newtons to the left, that would be 0. No movement is able to occur. Now, let's go on to the next thing and see what we're gonna what would happen here, okay? So just hypothetically, let's see what would happen. Let's say that we really need to move this couch and we have a friend come over and help us, okay? And they are also able to push at 100 newtons. So now you have 200 newtons pushing on your couch and the couch is still only pushing back 100 newtons. What's gonna happen next? You're actually gonna be able to start moving that couch because 200 plus negative 100 would be what? 100 newtons, you have movement. Now that brings me into my next point. What you just saw was sliding friction. Sliding friction is going to be friction that occurs when two objects are moving past one another and you have force applied to each of them. So, again, we have movement happening in sliding friction. That's how it's different from static friction. So let's say that maybe you grow. Maybe it's a year later and you've grown and you're able to push a lot harder than you were. Maybe you started working out. So let's say that you push that couch at 200 newtons and the couch is pushing back at 100 newtons. Guess what's going to happen? You're going to be able to move your couch. So the last type of friction I want to talk about is fluid friction. So the word fluid is going to be really important to us. Fluid is just a liquid or a gas. There's a common misconception that when you say the word fluid, you're talking about just a liquid. Actually, fluid is a liquid or a gas. So, with fluid friction, you have a liquid or a gas pushing against an object. It's friction that's applied by something that is a liquid or a gas. Now, where in the world would we have liquid or gas pushing against something? Well, in a lot of situations. This guy here in the picture is pretty happy that there's some gas pushing back on his parachute, otherwise he'd be in big trouble, right? And then you have swimmers. As they swim, they are having to work against fluid friction of the water. When you sail a paper airplane through the classroom, hopefully you don't do that, but you are dealing with fluid friction of the air particles against that paper airplane. So let's do another little free body diagram and look at what this looks like. Let's look at the little parachute scenario here. So when we talk about fluid friction, another word for that when you're talking about air particles, would be air resistance. And then in this little diagram, you see the little parachute guy. He's got the force of gravity pulling him down. But what is kind of pushing back up on that parachute? Well, that's air. That's fluid friction or air resistance that is going to be pushing back up. And the reason why he's not falling as fast is because there is an opposite force that is opposing that gravitational force pulling down. So that's what's making him fall. He's still falling. That gravity arrow is a little bit longer, okay? Still falling, but not as fast because of this frictional fluid force that is being applied to the parachute. So today we learned several things. First of all, we explained what the universal law of gravitation was. And we know that gravity depends, the strength of gravitational forces depend on two things, on the mass of the object and the distance between them. We also described how different frictional forces worked. We learned that there are three types of friction. We have static, sliding, and fluid friction. And we also got to talk about this guy. By the way, you're going to hear a lot more about him in the next video. We're going to talk about Newton's laws in the next video. And I nerd out pretty bad when we talk about Newton's laws because it's super cool. Alright, so thank you so much for watching. Make sure you're studying for your Friday quizzes. And let me know if you need anything. Have a wonderful day.